I'm so excited to introduce you to Dr. Xian. I'm sure I'm saying it wrong. I'm trying really hard.
Very good. It's actually good. Yeah.
Pretty good? Okay, good. And we're so excited to have you here because you are the brains behind a program that we recently started using here at Made for Math called COMPS. And so we wanted you to come and chat with our team because they've had an opportunity to implement it with some of their students. Not all of us are here, but we've got some core people that have been implementing it. So today's purposes is we're just going to be talking about your program and what kind of sparked some of those things for you and why you chose to research those kinds of things. And then obviously Braylee on our team is here with us and Brittany too, and they'll have questions as well. So anyways, I thought it would be really interesting to begin with, how did you get your start in studying special ed with a focus in the mathematics side, and which ultimately led to this word problems? I think that's really interesting. I know a little bit of the story, but I know these two haven't heard it.
Yeah. Thank you, first of all, having me today. And I'm glad that I have time, the opportunity to meeting you all. That's kind of a long story. I came from Shanghai, East China Normal University, got my master's degree, bachelor degree in psychology. And then at that time, of course, in China, there was no special education. Just started in 1989. The government wanted to establish that program and want us to teach. And I don't actually have any background, right? Because I'm a psychology major. So they started to have us attend a training, the experts from the United States, and then talk about special education. And then, well, since I have to teach the following year, so I thought I better learn myself first before I can teach a student. So I applied, the scholarship. And at that time, luckily, I got these, it's called a fellowship, graduate assistantship by working in the group home at Lehigh University. So I thought that's a great opportunity because there is money. Otherwise, I won't be able to come. So after I get my master's degree actually in severe disability. At that time, it's called severe disability because we don't have a professor in mild. And then upon graduation, we have a professor, Dr. Jitendra, coming to Lehigh. She's focusing on learning disabilities, difficulties, and I thought that's what I want to do. So I eventually shifted from my focus from severe disabilities to mild. At that time, I don't really know what I should focus on. I don't have any background, and so I thought that my English is pretty bad. I never have formal training, never have any formal training English. So I won't be able to study reading. So I thought of math, I can understand its number, right? And so I started with a literature review. And that's an eye-opening experience because I discovered that United States students are not performing at top across the globe. And that's fascinating. I thought the United States advanced in everywhere, everything, every aspect. But anyway, the students are not doing well in math. And that really triggered me to study the curriculum, to study the literature, what are the interventions, and even conduct an international comparison to see how, US students compared to students, for instance, in China, solve these elementary word problems and why they have specific problems in some types of word problems. And I eventually found that there is a significant difference in terms of the way we teach mathematics in China or Asian country or in the United States, and even in the curriculum. So the curriculum design is very different. And we hear pretty much like a talk, each concept or skill isolated, not really make them connected. But at that time, at least the curriculum in China, it's really emphasized the problem structure, or if you say problem schema, they present to students with the same story, but manipulate kind of the construction of a problem and make it like with the unknown in every component possible. And the student have to really grasp the structure of the problem or underneath structure of the problem or mathematical relationship. And they really focus on math. That's the big idea. They focus on math. The story is really short. I call them make the problem because there's no story, pretty much. Just like a number, and then just make them a word problem. So really they focus on mathematics, the mathematical relationship, rather than the surface feature. So I eventually, following my advisor, Dr. Chitendra at that time, I started a literature review. I started a meta-analysis. I learned the meta-analysis myself and figured out that representation strategies kind of more effective, or if you represented a problem structure, will be more effective, even more effective. So I started working with her on schema-based instruction intervention to help students. And later I discovered that because students have to really classify problem types into, if we're talking about addition, subtraction, the change problem, the comparison, the combine, the group. And after that, you have to remember the diagram for each problem type. Mm-hmm. And then you have to represent in the diagram, but then still does not tell you the solution strategy, whether you add or subtract, right? And then students were taught those rules, such as if the total is given, then you subtract. If it's not given, you add. And still end up with guess and a check, right?
Yeah.
It's still... students don't know how to come up with a solution plan. And so I thought, why we have to focus on this story, right? Underneath is the same, it's part of our whole. So what if they don't have to, make a distinction among all these problem types? Even myself, researchers in the group that we work with the student, sometimes we had a disagreement or had a hard time to make a distinction, whether this is a change, whether there's a change in time, whether this is combined or group. So why this matters? And I thought, well, Chinese, they don't really focus on the story. They just focus on underneath the mathematical relationship. So here's the papa hole, that's it. That's just one mathematical relationship. And I thought, so if Chinese students can do that, dealing with algebraic equation, why American cannot do that? At that time, of course, the teacher, again, long ago, elementary student does not, you're not allowed to introduce equations. So I come up with a strategy was, actually just leaving the equation out, but still the idea is still there. But later, of course, the Common Core and the NCTM, the standards all coming out to emphasize algebra. So then I don't have reservation. I just go forward with this equation. So that's how I eventually ended up with creating my own theoretical framework. I call it conceptual model based because I want to focus on mathematical model rather than the surface feature or the story. And I even found the theoretical foundation for that. And there is a German mathematician actually come up with this model theory. You have two worlds, right? One is the real world, dealing with all these situated problems, the context, everything. One is the mathematical world that all these mathematical relationship is decontextualized from the story. So it basically looking at the math relationship rather than the story. So my world, I want to really focus on the mathematical relationship. I don't devalue the understanding of the problem, right? You still have to understand the story in the beginning first, but eventually you want to move students above and beyond the story. So I want to let them expose to the mathematical world, look at the underneath the mathematical relationship, and see the connection. That's more importantly for students to see the connection, the big ideas. For instance, part whole is a big idea for additive problem solving. And for multiplication division, you have a unit rate, a number of units or product. That's also the big idea for multiplicative problem solving. So it's just one model rather than several diagrams. Students have to remember dealing with, have to remember the types and remember the diagrams. So I hope that you will see the beauty or the benefit of that, because that really reduces students' burden, right? They don't have to remember too many types, and it's just one model. Of course, the caveat is that you cannot just, hey, here's my model, you take it, right? It's very abstract. For elementary students, this is a very abstract concept. Box, 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 what do you mean, right? So we really have to help students to construct that concept through representation, represent all types of real world situated problems onto that model, and for them to see the connections. There are so many different situations, right? Group, combine, change, whatever, comparison, but eventually coming down to the mathematical relationship is just the part whole. So that part is important. We have to help them understand the connection between their real world, between their instinct knowledge and the mathematical abstract model. So I want to actually hear from you the obstacles or difficulties that you run into when you teach that model. And then I'm going to talk about what we can do to address the gap.
Sure. I think that would be great. And before we discuss that, Braylee and Brittany, I'll give you a minute to think about like what the obstacles were you faced. But what I love about your program is that it's very generalizable to future things that students are learning. It's an algebraic model. And that's one thing we try to do at Made for Math. Anything we're going to teach the student, we want to make sure it's a skill they're going to use for the long haul. And so your program really does that. Whereas I felt like Jahintra's work, even Carpenter's work, there were so many things to be memorized. And I didn't see a transference that was easy and straightforward to higher levels of math. Whereas with your program, it's very clear this is something you can learn and apply and take with you into those upper grade levels. And so that's why I picked your program, and I think why my team is loving it and the students are responding positively to it. And so maybe in the editing process, I'll add a visual here so people can see what we're talking about, the model and how simple and straightforward it is. But what about you, Braylee? I know you implemented it with your students. What kinds of things did you run into or bump into that were a little bit of a challenge, but you were able to kind of overcome?
Sorry, I've got a noisy one in here, but the biggest hurdle is trying to keep out that algebra language with some of my kids, especially when we got to like relating the part whole to subtracting. I know that was one issue that I needed to keep going back and refreshing how to do that, especially because my kids are older and they have had a little bit different types of math introduced to them. And then the only other thing I did is I adapted it for multiplying fractions for one of my students. It did well, especially when you have a whole number multiplying with a fraction. But a fraction times a fraction, it took a little finagling, but I was able to get it to work for a couple of my students. Still a lot of repetition. And I know the biggest thing is mathematically, it doesn't matter which order you put the fractions in when you're multiplying, but it makes a difference when you're talking about it. And so it was hard to decide whether to correct them or not with things like that. But yeah.
Thanks. So actually, you are actually already involved in the fraction. This is the multiplication division you are talking about, right? Yeah.
I don't have the younger kids, so I didn't do as much of the part whole. I did them, but with fractions. So they were doing part whole with fractions, which was a little weird because a fraction is a part. So I introduced it with regular numbers, but sometimes that was a little confusing for them.
Will you be able to use the bar model hopefully to help, or some more concrete image picture representation?
Yep, I did a lot of those with it as well. But the kids really liked having the plug it into the different places, and I do feel like it helped. I feel like a couple of these kids went through the adding and subtracting fractions faster than some of my other kids that I didn't implement it with. So that was could have been coincidence, but something kind of interesting I noticed.
These models, I think it's better we started with, I'm sure you did, it was integer whole number, so that after they grasp the concept or the model, then you can do whatever fraction, other numbers. Sometimes with this fraction, maybe modeling a fraction, you can still modeling with pictures, maybe a little bit harder, or even bar model, I think would be harder. Maybe number line would be easier. But you can always back up one step with the concrete representation or semi-concrete. To hopefully help them see how these part makes up the whole. But I think, you must start with whole number. Eventually, after you kind of trusted in this model, then you, as long as you represent it into the model, you don't really have to draw the picture anymore, because you already constructed that model, and you can just apply it or use it because you know that works. And then we don't have to worry about how large the number is, or how, whether it's fraction, whether it's whole number, right?
Oh, yeah. I was just going to say, because I think I watched one of those lessons, Braley, that you taught with the fractions. And I think you changed the language too, which was helpful to relate it more to the fractions that you were doing in the template. Because that's the thing. I don't remember what it was.
Fraction times fraction, I did have to change the language. It was like total part and partial part that I had to call it. And it really did. I mean, that student did really well. I actually was even assessing them today on some of the stuff to see how they retained it after a short break. And it really did help. So I'm trying it with a couple other of my students as well to see if it will work.
That's really dealing with the calculation part, right? The fraction calculation. Yeah, I think there was a lot of research. One of them, I think, at least I know, Jessica Hunt, and there are a couple of others focusing on fraction. I might introduce some of the paper. Maybe they will talk more. I don't know if they address the calculation part in terms of conceptual understanding that related to the calculation of fraction.
And what about you, Brittany? What challenges did you run into using the program?
I feel like, so I did mine mainly with whole numbers with my kiddos, because I kind of did it to where I started with the part whole and doing the comparison, and then I went straight from there into doing the multiplication and division, but still using like really simple numbers. We had some problems where we were just using like multiples of 5 or multiples of 2 to make it simple for the kids. So that really helped. But I feel like my students did struggle a lot more with the multiply divide than with the part whole. I feel like they grasp the part whole fairly quickly. But again, I also have some older students. But I do feel like where I really started to get stuck is when I tried to throw in like a multi-step problem. And that got challenging because, you might need to use 2 different equations, like a part whole and a comparison, or equal groups and part whole. So that was challenging for my students. Even if I still use simple numbers, it was something we had to still use like visuals or manipulatives, because they got kind of got lost at trying to set up 2 separate equations. in doing that. But overall, I feel like it was pretty successful, especially since I used, numbers that were easy for them to work with.
I think I remember the book actually also included simple two-step. Am I correct? Or if I remember?
You did. Yeah.
So you have to answer for that, the partial answer, and hold it there, right? And then
right.
Go to the next part. So we really have to register all the information down for the students, especially, if we are dealing with students with either learning difficulties or twice exceptional. Working memory is always a big issue. Even myself, before I learned algebra, I found that some problems really difficult for me to solve, especially, remember those days, like the water goes into the tank, and then in the meantime, the water goes out of the tank, and like a calculator. So until I learned the algebra, then I feel like I'm able to handle it because I can register down each piece of information with an expression, and I don't lose it. So I guess, we have to help them to register down everything. And my student, they even, like when you read the problem, kind of make notation. Perhaps you guys have been doing that too, on the problem when they read it to comprehend the problem, like which is the part, and then you put P there, or P1, P2, excuse me, sorry. And then so either this is total, or this is a unit rate or number of items in each group, or the reference, or whatever you call it. So if you make a notation, that also help them register the information down, and then eventually they represent it into the diagram so they don't lose the information. All those things I think would help. Highlighting, use different color, always works, right?
Yeah, absolutely. And Braylee and Brittany, I'm curious too, like what were some of the responses from your students using their program as they got more comfortable with it? What kinds of good, positive things were you hearing from them about it?
I feel like they were more willing to try word problems. My one main student who I started with and did it with consistently, she was very resistant to word problems before we started. And by the end, I feel like she was even willing to like tackle word problems on her own, because she was homeschooled. So her mom would make her do like work outside of our sessions. And so she was more willing to like try word problems using the templates.
That's awesome.
She felt more confident. So
that's awesome.
That's good.
That's good to hear. Yeah, at that time right now, actually, we have the computer program. Unfortunately, there's a glitch in terms of the platform does not support some of the function. And I played recently, like did not work smoothly. So I think with that tool, if that works smoothly, right, it really helps use manipulative cubes or whatever you want to write, although it's virtual manipulatives, but that's really helped them to construct the concept. But of course, without that, we can use physical manipulatives to help them if they don't understand concept. And I think so Brittany, I don't know if you running into some students who were taught keyword strategies or other strategies at school, and then there was, some of the students in my research group, and they will have intention to change the plus sign into minus whenever they see these different problems. I don't know if you run into those things.
Oh yeah, for sure. But I do think I feel like my students had a hard time with the multiplication division, identifying the unit rate. So I did tell them a lot of times, when you see the words like per something else, that's going to signify unit rate. So I'm like, okay, I guess sometimes keywords are okay, but
this is different than keywords strategy. This is teaching them actually using these keywords, teach them the concept, right? But keyword strategy, you don't look at anything else. So when you read the problem, you just circle that one word together, for instance, that's just add. Then you don't look at any other stuff. This is different. What you are doing is not so-called a keyword strategy, although we are teaching these keyword Yeah, I do too, to help them understand what is the unit rate, right? That's really abstract concept. Of course, you can say number of items in each group. Sometimes not group, right? I know that there are couple of researchers actually, they use my strategies, and but they really only teach the equal group. So they teach you a number of items each group, and that's nothing wrong. But when you comes to buy something, and then it's really the unit rate, right? Yeah, the unit price. So it's the number of items in each group. So we just have to expose them to different kind of situations. Hopefully they will be able to construct a concept at the abstract level. So no matter it's number of items in each group or in each basket or container.
Well, I think that's good too, because it helps that language of using the unit rate so early on. It's going to help them in pre-algebra when they do slope and they do, proportions and ratios and all those things that, that's all going to tie in, and it'll make more sense if you start this like super young, if they already know the term unit rate in elementary school.
I really appreciate you say that, because people, a lot of researchers in the field kind of just want to make sure students read it, understand it more easier. So then they avoid that language, and actually mathematically it is unit rate. And when we talk about comparison, and it is the reference unit, it's not like some people, I just read several studies, they change it into reference set, and it's really not rigorous mathematical term. It is reference unit. So I really appreciate you say that. It's down in the road, eventually you learn algebra, that's going to help them make the connection.
What about you, Braylee? What were your students saying about this program?
One of my students got very upset when I wouldn't call it a part whole question, like, because partway through, like, I was just like doing stuff and I kind of forgot about it. And she goes, wait a second, this is a part whole question. I need my little diagram.
That's good.
And even now we've been adding and subtracting fractions, and she's very, very good. She doesn't need the little picture anymore, but she'll say, okay, so this is a part and a part, and so I need to figure out what this whole is. It might not equal one whole, but I need to figure out what the whole is. And she's still figuring out how to convert like fractions that they have uncommon denominators, but she does recognize that they need to be converted. And that's something like with adding fractions, a lot of my kids, like one kid I know for sure that I didn't implement the program with, is still trying to add the denominators. But she sees it as these are two parts. I need to make it so that they're on the like same playing field and adding them. And she'll call it a part whole all the time. Wow,
that's amazing. I hope you have those. I don't know if you have these video footage. And
we do. Yep.
I would appreciate if you could share with me, because this is really help us to see how students construct a concept, right? And actually, based on what you said, actually, part whole help them to think you have to make it a common denominator, right? Rather than just adding these bottom numbers together, adding the top number together. Wow.
I'll see if I can find that one.
Yeah, I really would like to learn from your students.
Yes, that's so cool. Yeah, I think your program is really awesome. And I agree with you about the language. Like, I think we are too quick to assume that the appropriate math language is below, like too hard for students. So we go way lower, simplifying it. But I think the opposite is true. We do a lot of vocabulary word study. And so, the word referent, we could do a word study around that. What do the parts of that word mean? Where does it come from? What is it talking about? And I think students are smart enough to glom onto that. They're smart. They understand. And I think we should not, shy away from the language of mathematics, but embrace it and really hone in on, okay, here's the language of the child. and here's the language of mathematics, and build that bridge together of finding a way to talk about this vocabulary in a way that's meaningful to them and helpful. So I loved that about the program too, that you're using the correct math language. And I learned so much just going through the program. So it's really,
I at that time when I just looking at compared curriculum US and China, and so the multiplication just fact product, right? Fact product, factor, the two factor, who are they? We don't really talk about it. And so people, of course, you can of course switch to position. That's the property, of course, everybody know. But in China, they started with really like serious about, first factor is the unit rate, if we call it, number of items in each group. So you have this, fixed, and then that's, I think, the English reiterate, right? Another one, yet another one. So we always put this unit rate as the first factor, but in US, because of the English, like 5 groups of 3, and always groups comes first. So a lot of other people who adapted my strategies, they always put the number of group first, because that's consistent with the English. But when I worked with the schools, I consulted a teacher. I said, what should I do? Because English, that comes first. And she said, well, why we have to follow the English language? And so, well, if conceptually that helps students mathematically, then we want them to think about mathematically, not just the English, okay? And so she supported the way I do it and said, okay, let's just put still the unit rate first, because that's the unit you work with, right? Without that, how do you reiterate or iterate that composite unit? So I kept that order, but of course we will based on individual student. If a student more adapted to the number of groups comes first, that's always, we can have that flexibility based on whatever student's preference or needs. But as long as they understand these two factor has unique meaning, then that's it. That's the concept. So I think by making a distinction, that's why at that time I use different diagram, the figure, and use different color to indicate they have unique different meanings, rather than just the two numbers, put them together. So I think that helps them to understand they serve different roles, not like additive part are the same, and multiplication is not really repeated addition. Each factor has unique meaning. So
yeah,
I think you have a good point there, because something I'm thinking about is with multiplication, if you're just doing like blank groups of blank and you ask the student, well, what's the group? A lot of times they can't tell you, they don't know what the group is. But if they can identify the unit rate, 12 eggs per basket, well, what's going in, what it's going in is your group, the basket. So I feel like it does help to identify that unit rate first. And then from there, they can figure out, oh, what's the group?
Yeah, if you want one more or 3 more, 2 more or 3.
Right.
And that even consistent with the comparison, the multiplicative comparison, right? You have the reference unit first. What is basically the unit? And then you want to reiterate, 3 times, 5 times, 7 times, whatever times, right? Times of something. And then that's something already there. But in other way, you don't even have that unit there. You don't have a reference there. How do you reiterate, right? So it's actually conceptually, it's harder to think about. But it's interesting. Yeah. So people want to go with the English language and easy on student. And I'm not sure if actually, I hope one day we can compare to a study. That would be interesting to see, right? And which one actually serve a better purposes or get a better result.
Yeah, there was one that I did have to switch it to groups of. The student was just old enough and had been taught that so many times that it wasn't worth the effort. And so I did just copy and paste and like switch their spots. And he did fine with it. But yeah, now that you guys have mentioned that, I'll probably try that with some of my other students instead of just sticking with what I was comfortable with.
To see how it works. Yeah, I'm always curious about this. But of course, as long as you said, make the distinction of these two factors, talk about the meaning of that, it should be fine. I'm just wondering, yeah. And even I'm thinking about Chinese students, right? American students, you have this English language as a factor there. So how does that work? Very interesting.
I know, you did great. And have you ever considered maybe doing like some sort of training course?
Yeah, I would love to do that. I can even invite my colleague. She's in math education. She did a lot of research in terms of the number sense and composite unit and that part. Perhaps she can join me. She's really good at professional development, actually. She's the expert in professional development, Dr. Sina Kesterberg, my collaborator.
Yeah,
I would love to do that. I would love to do that. So
that would be awesome. I know we would enjoy that. So
yeah.
Well, we're running short on time, and I hate to go, but we'll have to meet again after more of our team goes through this, and we can glean some more from you and discover what they experience too with the program.
Definitely, yeah. And in the meantime, if you come up with some questions, maybe you can shoot me the email, and I can be prepared better, maybe.
Sure.
Question. But I always love to hear from you, from your students. That's really important. And then we will talk about how we can work together, maybe submit a grant proposal and get money to support what we do.
Absolutely. That was so nice to have you today.